this episode, we are going to step back and look at the bigger architectural question that ties everything together, which is how to build security into cloud environments from the beginning rather than layering it on afterward. Cloud providers offer a wide range of native security capabilities, including identity controls, encryption options, network segmentation features, logging systems, and policy engines. The challenge for beginners is not the absence of tools, but the abundance of them, because it is easy to enable features without understanding how they fit into a coherent pattern. Frameworks for built-in security help you map those provider-native capabilities into repeatable, reliable design patterns that support your security goals consistently. Instead of making isolated configuration choices, you assemble a structured approach where identity, network, storage, automation, and monitoring reinforce each other. Built-in security is not about adding more tools. It is about arranging what you already have into a system that works predictably. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to think about frameworks is to see them as organizing principles rather than checklists. When you hear the term Zero Trust, ZT, for the first time in this context, think of it as an architectural mindset that assumes no request should be automatically trusted simply because it originates from a familiar network location. This mindset influences how identity, device posture, and network segmentation are designed across the environment. Another example is the idea of defense in depth, which means layering controls so that the failure of one does not collapse the entire system. Cloud providers supply the building blocks for both of these approaches, but it is up to you to connect them intentionally. Frameworks give structure to those connections, ensuring that features are applied consistently rather than sporadically. Structure reduces confusion and improves resilience. Mapping provider-native identity features into a reliable pattern begins with strong central authentication and precise authorization. Most cloud platforms provide centralized identity services that integrate with multi-factor authentication, MFA, role-based access control, and conditional access policies. A built-in security pattern would define that all administrative accounts require MFA, that roles are scoped to least privilege, and that conditional access evaluates context before granting sensitive access. Instead of configuring these controls differently for each service, the framework defines a consistent identity baseline. Beginners sometimes enable identity features piecemeal, which creates uneven protection. A mapped pattern ensures that identity protection is systematic and predictable across all workloads. Network capabilities provided by cloud platforms can also be mapped into clear patterns that reinforce segmentation and controlled exposure. Virtual networks, private endpoints, and security groups are powerful features, but without a guiding framework, they can be configured inconsistently. A built-in security approach might define that internal services communicate only over private connectivity, that public endpoints are limited and monitored, and that management interfaces are never exposed directly to the internet. These decisions become design standards rather than optional settings. Beginners sometimes treat network features as flexible utilities, but flexibility without structure leads to drift. A framework turns flexibility into disciplined architecture. Encryption features offered by providers are another area where mapping into patterns increases reliability. Most cloud services support encryption at rest and in transit, often backed by centralized key management systems. A built-in security framework would define when default encryption is sufficient and when customer-managed keys are required for higher assurance. It would also specify how keys are rotated, who can access them, and how usage is logged. Instead of enabling encryption sporadically, the framework ensures it is the baseline expectation. Beginners may assume encryption is automatically applied everywhere, but explicit mapping ensures no critical resource is overlooked. Consistency strengthens confidentiality. Logging and monitoring services provided by cloud platforms are essential for visibility, but they only become effective when integrated into a cohesive pattern. A reliable framework would define which logs are enabled by default, where they are centralized, how long they are retained, and how alerts are triggered. This prevents gaps where one service is well monitored while another is nearly invisible. Centralized logging also supports incident response by correlating events across identity, network, and application layers. Beginners sometimes enable logs without considering retention or analysis, which limits their usefulness. A mapped pattern ensures logging supports both compliance and operational security. Policy enforcement tools offered by cloud providers are the backbone of automated guardrails when integrated into a framework. These tools can evaluate resource configurations against defined standards and block or flag violations. A built-in security approach defines baseline policies for storage privacy, network exposure, identity scope, and encryption requirements. Rather than relying on individual teams to remember security rules, the framework encodes them into enforceable logic. Beginners often struggle with policy sprawl, where rules exist but are not consistently applied. Mapping policies into a structured pattern reduces ambiguity and drift. Automation capabilities, including infrastructure as code, IAC, also become more powerful when guided by a security framework. Instead of writing infrastructure definitions that vary by team or project, the framework defines secure modules and templates that reflect approved patterns. These templates include proper segmentation, logging, identity controls, and secret handling by default. Automation then becomes a vehicle for spreading secure design rather than a source of unpredictable variation. Beginners may focus on automation speed, but framework alignment ensures speed does not compromise safety. Automation and architecture must move together. Another important dimension of built-in security frameworks is governance, which clarifies roles, responsibilities, and decision authority. Provider-native capabilities allow detailed control, but without governance, those controls may be applied inconsistently or not at all. A reliable framework defines who approves exceptions, who reviews logs, who owns key management, and who maintains policy definitions. This clarity prevents confusion during both routine operations and incidents. Beginners sometimes assume governance is separate from technical design, but in reality, governance enables consistent technical application. Defined ownership strengthens accountability. Integration across layers is what transforms a collection of features into a reliable pattern. Identity controls should inform network segmentation, which should align with encryption and logging policies. For example, a zero-trust mindset influences how identity and device posture are evaluated before granting access to segmented services. Logging from those services should feed into centralized monitoring, which can detect anomalies tied back to identity decisions. Each layer supports the others rather than operating independently. Beginners benefit from seeing these connections because it reduces the feeling of isolated tools. Integration creates coherence. Built-in security frameworks also support scalability because they provide a repeatable blueprint as environments grow. When new projects launch, they can adopt established patterns rather than inventing their own. This reduces onboarding time and decreases the risk of misconfiguration. It also ensures that as the organization expands into new regions or accounts, security posture remains consistent. Beginners often worry that scaling cloud infrastructure will multiply risk, but frameworks mitigate that effect by standardizing design. Standardization reduces variation, and variation is a common source of vulnerability. Continuous improvement is another element of effective frameworks because threats evolve and provider capabilities change over time. A static framework eventually becomes outdated, so it must be reviewed and refined regularly. Lessons learned from incidents, audits, or new service features should inform updates to baseline patterns. Automation makes these updates easier to propagate once defined. Beginners sometimes see frameworks as rigid structures, but they are better understood as living architectures that adapt while preserving core principles. Adaptability ensures relevance. By the end of this episode, the overarching lesson should feel both strategic and practical because it connects individual controls into a durable architecture. Provider-native capabilities are abundant, but without a framework, they can become fragmented and inconsistent. Mapping identity, network, encryption, logging, policy, and automation features into coherent patterns creates built-in security rather than bolt-on fixes. Governance and integration ensure those patterns are applied consistently and evolve responsibly. Scalability and continuous improvement keep the architecture resilient as the environment grows. When you treat cloud security as a structured framework rather than a collection of settings, you create an environment where protection is not an afterthought, but a fundamental property of the design.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.